science students 3 marks. For data science students 12 to 15 marks. So data science students they're asking around 12 marks weightage. DA, data science, artificial intelligence, around 12 marks weightage from the linear algebra. What are the topics we are having from mathematics, linear algebra, one more calculus, probability and statistics. These three. These three weightage is around 35 marks weightage. Last year, 2026, they asked 35 marks. 2025, near about 40 marks. Data science students. Yeah. We're coming to next. Okay. For computer science students, it's a 3 marks weightage. Okay. Linear algebra. What are the subtopics? See, totally three topics are there. So, pen color. White, huh? Okay. Yeah. What are the subtopics in the linear algebra? Types of matrices. First one is types of matrices. See, we have near about 30 different types of matrices. Types of matrices 30. Second is the types of matrices. What are the types of matrices we have? Row matrix, column matrix, rectangular matrix, square matrix, null matrix, upper triangular, lower triangular, diagonal, scalar, transpose matrix, and symmetric, skew symmetric, orthogonal matrix. What is the condition for symmetric matrix? Anybody? Symmetric matrix condition. A transpose equal to A. Skew symmetric, A transpose equal to minus A. Orthogonal matrix A into A transpose A is equals to I. So I'm expecting everyone concentrate. DA students 10 marks to 12 to sometimes 15 also. DA students CSC is 3, but DA students mass only deciding factor. We have to do work hard. Types of matrices, near about 30 different types of matrices. Then next rank, third system of linear equations. System of linear equations. So what are the linear equations we are having? System of linear equations. What are the linear equations? Non-homogeneous, homogeneous, non-homogeneous, homogeneous, non-homogeneous and homogeneous. What are the non-homogeneous equations? What is the form of the non-homogeneous equations? A1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. What are the homogeneous equations here? A1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, a3x plus b3y plus c3z equal to 0. How to identify they are non-homogeneous and homogeneous? At least one of the constant term non-zero. At least one of the constant term is non-zero. In the D1, D2, D3, at least one of them is non-zero, then it is a non-homogeneous. If all are zeros, then it is called the homogeneous. And what are the different words related to these terms? Consistent and inconsistent. And also we have the trivial solution definitions. Anybody, what is the consistent? What is the meaning of the consistent? When the system of linear equations is said to be consistent, if it has unique solution or infinite number of solutions. Unique or infinite number of solutions. Inconsistent means what? No solution. Consistent, inconsistent. And trivial solution. One more word is the trivial solution. Trivial solution means what? 0, 0, 0 is called the trivial solution. Trivial solution is associated to homogeneous equations. See, some of you are only sitting, they are not concentrating. 4 5 members I'm observing. Thing is, what opportunity from your college? My suggestion: work hard for the data science and artificial intelligence, and also what is another one? Computer science students use this opportunity. So try to get below 100 rank. Below 100 rank, sure, no doubt you will placed into top IITs. Up to 500 is okay, no problem. After 500 is difficulty. So up to 500, if you will get top IITs, no doubt, top 7 IITs. Still, some of you are getting doubt. Will you get? Is it possible for us to get 500? We should not think like that. We have to always think that possible, right? Work hard, no problem. Huh? System of linear equations. See here, d1, d2, d3, at least one of them is non-zero, then we are calling is what? Non-homogeneous. All are zeros we are calling as a homogeneous. For finding the rank, what are the methods we have for finding the rank is, what are the methods for finding the rank? One is determinant approach, second is called the echelon form. Echelon form, hope all of you heard the echelon form? Echelon form, and one more is determinant approach. And the fourth one is the characteristic matrix. Characteristic matrix. Characteristic matrix is what? A minus lambda I. A minus lambda is the characteristic matrix. What is the characteristic equation? Characteristic equation is what? Det of A minus lambda is equals to 0 is the characteristic equation. Characteristic matrix, characteristic equation. Hope all of you have studied these two, characteristic matrix and characteristic equation. So then next, very very important, eigenvalues and sure type, eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Then next, sixth one is the Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. What is the statement of the Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. What is the statement of Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. And if you observe the seventh one, LU decomposition. LU decomposition is a small topic. LU decomposition. What is LU decomposition? Every square matrix can be expressed as the product of the lower triangular and upper triangular. LU decomposition. Lower triangular and upper triangular. Yeah, coming to next. So this is our syllabus in the linear algebra. Yeah, let us move to concepts. Types of matrices. Today we are planning these three up to system of linear equations. Up to system of linear equations. Concentrate. All are very very important. All of you copied syllabus? Just note down. This is our syllabus. Types of matrices, rank, system of linear equations, characteristic matrix, characteristic equation, eigenvalues and eigenvectors, Cayley-Hamilton theorem, LU decomposition. LU means what? L means lower triangular, U means upper triangular. L is lower triangular, U is the upper triangular. Okay. So matrix definition. Let us write the matrix definition. Just note down the matrix definition. Matrix definition. Matrix definition. Matrix definition. A rectangular array of elements. Write down matrix definition. A rectangular array of elements. Matrix definition. A rectangular array of elements arranged in matrix definition. A rectangular array of elements. A rectangular array of elements. A rectangular array of elements arranged in a rectangular array of elements arranged in horizontal lines and vertical lines. A rectangular array of elements arranged in horizontal lines and vertical lines is called matrix. Horizontal lines and vertical lines is called matrix. What is the name of horizontal lines? Horizontal lines are called? Horizontal lines are rows. Vertical lines are columns. Vertical lines, columns. Horizontal lines, rows, vertical lines, columns. Next. What is the general form of the matrix? General form. What is the general form of the matrix? General form of the matrix is represented as matrix A is equals to general form of the matrix A11, A12, A13, so on, A1n, A21, A22, A23, and so on, A2n, and so on, AM1, AM2, AM3, and so on, AMN. So in this, how many rows are there? How many rows are there? M rows. How many rows? M rows and N columns. M rows, N columns. What is the order of the matrix here? M by N. Order of the matrix is M by N. M is number of rows, N is the number of columns. Order of the matrix. Order is equals to number of rows. Number of rows by number of columns. Number of rows by number of columns. Order of the matrix, number of rows by number of columns. If you take the example here, 1, 2, 3, 4, 5, 6. What is the order of the matrix? 2 by 3. 1, 2, 3, 4, 5, 6. Order of the matrix is 2 by 3. Uh, some of you are thinking whether they will ask order of the matrix in the GATE exams or no, they don't ask the order of the matrix. But for us, some knowledge. Will they ask order of the matrix in the GATE exam? No, no, they don't ask. It is a bacha question. So 1, 2, 3, 4, 5, 6. What is the order of the matrix? It is the 2 by 3. Now, some important notations we are having. What are the important notations here? I, J, M, N. So these are the important notations throughout our matrices. Of everyone concentrating. I represents what? Hello. I represent single. I represent single ith row. I represent single ith row. J represent single jth column. M represents number of rows. M represents number of rows. N represents number of columns. These four notations are very important. I, J, M, N. I, J, M, N. What is I represents? single ith row, J is a single jth column, M is number of rows, N is the number of columns. So this slide is clear to all of you? No confusion in this slide? Yes. Let us move to next. Yes. I, J, M, N. I is a single ith row, J is the single. Letters size. Okay. I is a single ith row, J is the single jth column, M is number of rows, N is the number of columns. Okay. Okay. So here I am going to write one matrix. Observe here. Hello. So I am expecting answer from all of you. I am expecting answer from all of you. Matrix A is Aij with order 3 by 3. Aij is equals to I minus j. A is a I minus j. One more equation is Aij is I into j. These are the two equations. Now let us construct the matrix A. Matrix A, yes. Tell me what is the first matrix A? Matrix A. What is I represents? I represents the row number. J is the column number. What is the first element? First element. First element. Hello. What is the row number of the first element? 1. Column number? 1 minus 1, 0. Second element, row number 1, column number 2, minus 1. This is what? Minus 2. 1, 0, 2 minus 3, 2 minus 3, minus 1, 2, 1, 0. All are understanding? I represents the row number, J is the column number. What is the row and column number of this element? Row number is the 3, column number is the 2, 3 minus 2, 1, 3 minus 3, 0. All of you are understanding? Just tell me this one, this matrix using this equation. Yeah, first one. 1 into 1, 1. 1 into 2, 2. 1 into 3, 3. 2, 4, 6. 3, 6, 9. Yeah. All of you are understanding what is the important of the I and J notations. Is it clear to all of you? Yes. Now, row matrix definition. Row matrix. Yes, all of you know what is the row matrix? Single row. Row matrix definition is what? Which contains single row and any number of the columns. Row matrix whose order is 1 by n. Whose order is 1 by n. Single row and any number of the columns 1 by n. 1 by n. N belongs to what? Positive integer. N belongs to positive integer. We should have the knowledge about the number systems. Natural number starts from where? Natural numbers are from where? 1, 2, 3, infinity. If 0 is added to the natural numbers, whole numbers and negative numbers, whole numbers and negative numbers are what? Integers. Integers and fractions are called rational. Rational and irrational is the real. Real and imaginary, complex. All of you are aware of this knowledge? Starts from natural. Natural from where to where? 1, 2, 3, infinity. 0 added whole. Whole numbers, negative numbers, integers, integers and fractions, rational. Rational is represented as Q. Rational and irrational is the real. Real and imaginary is the complex. Now I am going to ask you one number. Root 2 rational or irrational? Root 2 irrational. Root 2 irrational. Root 3 irrational. 1 by root 2 irrational. 1 by root 3 irrational. 1 by 2026. 1 by 2026 rational or irrational? Rational. If x rational, remember this very important point, x rational, 1 by x rational. If x irrational, 1 by x is irrational. As per this knowledge, what is 1 by 2026 is the rational. Is it clear to all of you? Yes. Row matrix. Example of the row matrix 1, 2, 3. What is the order of this one? 1 by 3. Row matrix. Next, column matrix. What is the column matrix definition? Column matrix. What is the order of the column matrix? M by 1. Hello, column matrix definition is what? M by 1. M by 1. M belongs to positive integer. M belongs to positive integer. M belongs to positive integer. Example 1, 2, 3. 3 by 1. Row matrix, column matrix. Row matrix, column matrix. Any confusion? All of your understanding? Row matrix, column matrix. What is the topic we are discussing? Types of matrices. It's a little bit big topic. Types of matrices. Yeah. Next slide. It's completed this slide. What happened? Yeah. Coming to next to rectangular matrix. Hello. Rectangular matrix. What is the definition? Rectangular. Hello. Rectangular matrix is what? M is not equal to. All of you know M is not equal to N. Rectangle number of rows not equal to number of columns. Rectangular. Square matrix. Square matrix is M is equals to N. What does it mean? Number of rows is equals to number of columns. All of you can identify what is a rectangular and square. Yes. 1, 2, 3, 4, 5, 6. Hello. 1, 2, 3, 4, 5, 6. Square or rectangular? Rectangular. 1, 2, 3, 4, 5, 6 is a rectangular. Huh? Rectangular or square? Rectangular. Next. Square matrix is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a square matrix. And this is also a best example. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also a best example of what type of matrix we are saying? It is a square matrix. This is also a best example of singular matrix. Singular matrix. What is the singular matrix definition? Singular matrix. Determinant equal to 0. Singular matrix. This determinant is 0. Observe here. Why this determinant? 1, 2, 3, 4, 5, 6, 7, 8, 9. Just observe. What is the shortcut for the determinant? All of you know regular determinant approach. How to calculate determinant? Everybody knows? Yeah. For any row, any column, how to calculate the determinant here? First row, I am expanding determinant 1 into 5, 6, 8, 9 minus 2 into 4, 6, 7, 9 plus 3 into 4, 5, 7, 8. Yeah, calculate. Tell me what is the answer? All of you calculate determinant value. Determinant value calculate and tell me what is the answer? Everyone. How much is the determinant value? What is the answer? 0. Determinant value 0. All of you try. Determinant value is 0. Yes. Then we have one shortcut to find the determinant value. Observe here 1, 2, 3, 4, 5, 6, 7, 8, 9. These two columns extend here 1, 4, 7, 2, 5, 8. ఇక్కడ observe చేయండి అమ్మా. Observe the shortcut for the determinant. What is the shortcut for the determinant? These two columns, hello, this diagonal multiply. What are the elements? 159 multiply 45 plus these diagonals multiply 84 and these diagonals multiply 96. Correct na? 96. Okay. These diagonals multiply completed and next diagonals we are taking. Yes. These diagonals next to these diagonals multiply 105 plus these diagonals 48, 72. All of you are understanding what is a shortcut? Very important. Determinant shortcut. First, what you have done? Determinant shortcut. Given matrix is as it is, we are writing. First two columns extending. First two columns and take these diagonals, add, minus. What is the answer we are going to get? 0. Yes or no? 225 minus 225, 0 is the answer. So this is a one way to find the determinant, one shortcut. Yes. All of you are understanding? What type of matrix is first one? Row matrix, column matrix, rectangular, square. Next, null matrix. Note down the shortcut for this one. Null matrix. Yes. See, my voice is clear to all of you up the last end. Yes. Next, null matrix. What is the null matrix? Null matrix, every element is 0. Without the knowledge about types of matrices, difficulty to understand. Try to understand the types of matrices. So my suggestion to all of you, when break time is given, try to go and come out after during break time. Meanwhile, you are going out and it is disturbance. So if you are a very serious, try to stay. Going outside and coming, it is a disturbance for others and me and everything atmosphere. What is a null matrix? If all elements are the zeros is the null matrix. Okay, next. Upper triangular matrix. What is the upper triangular? Yes. Upper triangular matrix. Hello. Upper triangular matrix. What is the definition of upper triangular matrix? Anybody? All elements below principal diagonal. Okay. So before going to this upper triangular matrix, let us discuss what is the principal diagonal. Principal diagonal. Principal diagonal. Principal diagonal definition. Yeah, write down principal diagonal. Principal diagonal. Every square matrix contains two diagonals. Please concentrate. Every square matrix contains two diagonals. Hello. What is the principal diagonal in this? 1, 5, 9. See, two diagonals. This is called the principal diagonal. How to define principal diagonal? Aij. Hello. Aij for all I equal to j. Yes. What is the definition of principal diagonal? Which contains how many diagonals we have? Two diagonals. Two diagonals are there. What are the two diagonals? 159. Another is what? 357. This is called the principal diagonal. What is another name of the principal diagonal? Leading diagonal. What is another name of the principal diagonal is called? Leading diagonal. Leading diagonal. So the other diagonal is called the off diagonal. OFF, off diagonal. Leading diagonal, off diagonal. Then what is the trace definition? Trace. Can you guess what is the trace? Trace. Sum of the principal diagonal elements. Yes or no? Sum of the principal diagonal elements is called the trace. 1 plus 5 plus 9. Trace. Sum of the principal diagonal elements is called trace. Everybody understanding? Sum of the principal diagonal elements is the trace. Next. Properties of the trace. Very important properties. Properties of trace. What are the different properties of the trace? First one, trace of A transpose. Yes. What happens trace of A transpose? Anybody? Trace of A transpose. If you interchange the rows and columns, is there any effect for the trace? Trace of A transpose is again trace of A. Yes or no? If you interchange the rows and columns, is there any effect for the trace? No effect. Trace of A transpose is trace of A. Second, trace of A plus B. When two matrices are added, what happens to the trace of A plus B? Is equals to trace of A plus trace of B. Second property, trace of A plus B. Trace of A plus trace of B. Third property, trace of A minus B. Trace of A minus B. Trace of A minus trace of B. Fourth property, trace of null matrix. Can you guess what is the trace of null matrix? 0. Trace of null matrix is a 0. Trace of null matrix is a 0. Fifth property, trace of unit matrix. 3 by 3 unit matrix. All of you know 3 by 3 unit matrix. What is the 3 by 3 unit matrix? 1 0 0 0 1 0 0 0 1. What is the trace? 3. Yes or no? Trace of unit matrix of 3 by 3 order. Trace of unit matrix of n by n is what? N by n. You are not responding. 3 by 3 trace is what? 3. 4 by 4, 4 by 4 trace. 4. 4 by 4 means what? 1, 3 zeros, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. What is the trace of the unit matrix of fourth order is 4. Trace of unit matrix of nth order? N. Trace of unit matrix of nth order is n. Next, sixth one. trace of AB. Trace of AB is equals to trace of BA. Trace of BA. And one more property, seventh property, trace of KA. Anybody? Trace of KA is how much? Trace of KA. K into trace of A. Trace of Ka. K is the constant. K into trace of A. Trace of Ka is equals to K into trace of A. Totally 7 properties. First property is what? Trace of A transpose is trace of A. Trace of A plus B, trace of A plus trace of B. Trace of A minus B, trace of A minus trace of B. Trace of null matrix is 0. Trace of Ka, K into trace of A. Trace of unit matrix of order n is n. Trace of AB equal to trace of BA. Totally 7 properties. All 7 properties are very, very important. Any new property you are observing? Is there any new property you are observing? Don't say all are new. Huh? Maybe some of you are saying we are listening first time, sir. No. Trace of, maybe one property is new for you. Trace of AB equal to trace of BA. Except that remaining all are well known to you. Very good. సో ఇవన్నీ తెలుసు అంటే మీరు బాగానే చదువుతున్నారని అంతే కదా. మీరు బాగా చదువుతున్నారా లేదా? మీరు 500 లోపు ర్యాంక్ వస్తుందని ట్రై చేస్తున్నారు కదా. ఎవ్రీవన్ ఈజ్ ట్రయింగ్ బిలో 500 ఉంది కదా కాన్ఫిడెంట్. అంతేగాని టైం పాస్కి రాస్తున్నారు ఎగ్జామ్ ఏం లేదు కదా. డోంట్ వేస్ట్ ద టైం, ప్రిపేర్ సీరియస్లీ ఫర్ ద ఎగ్జామ్. రైట్, కమింగ్ టు నెక్స్ట్. సింగిల్ ఫింగర్. ఓకే, నెక్స్ట్. అప్పర్ ట్రయాంగులర్ మ్యాట్రిక్స్. హలో, అప్పర్ ట్రయాంగులర్. What is the upper triangular matrix? All elements below principal diagonal zeros. Hello. All elements below principal diagonal zeros. Correct na? All elements below principal diagonal zeros. Yes or no? Upper triangular. All elements below principal. Below or above? You recollect your concepts, what you have studied. Below. Yes. All elements below principal diagonal zeros. Aij is equals to 0. Understand? Aij is equals to 0 for all. Aij is 0 for all. Hello. Now tell me, I less than j or I greater than j or I equal to j? Tell me. What is the I value of this one? I value is 2, j value is 1. I value is 3, j value is 1. I value is 3, j value is 2. My question is here, Aij equal to 0 for all. For all, I greater than j or I less than j? I greater than j or I less than j? You are not responding correct answer. Greater or less? Greater than. See here, మన ఎగ్జామ్లో, గేట్ ఎగ్జామ్లో రివర్స్లో కూడా అడుగుతాడు ఎగ్జామ్. ఇఫ్ ఏఐj ఈక్వల్ టు 0 ఫర్ ఆల్ ఐ గ్రేటర్ దెన్ జే, దెన్ వాట్ టైప్ ఆఫ్ మ్యాట్రిక్స్ అడుగుతాడా? అలా అడుగుతాడు. ఎవ్రీబడి నోస్ తెలుగు? Sometimes I am speaking Telugu. Everybody knows na? Very good, no problem. Yeah. Aij equal to 0 for all I greater than j. Is it clear to all of you? They will give this one and ask what type of matrix it is. It reverse. Reverse they will ask. What is that? What type of matrix it is? Upper triangular. You are all understanding? Very good. Lower triangular. Let us go to the lower triangular. Lower triangular definition. What is the lower triangular? 1 0 0 2 3 0 4 5 6. Now how to define in terms of Aij? In terms of Aij, how to define? Aij is equals to Aij equal to 0 for all. For all I less than j. I less than j, that is the lower triangular matrix. upper triangular, lower triangular. And there is no special triangular matrix. Whenever they are saying triangular means what? It is either upper triangular or lower triangular. Next, diagonal matrix. What is a diagonal matrix? So a little bit concentration. We are discussing what is the topic is the types of matrices. Concepts all are very important. Diagonal matrix is what? What is the diagonal matrix here? 1 0 0 0 2 0 0 0 3. What is the diagonal matrix definition? Aij is equals to 0. Aij is equals to 0 for all I is not equal to j. Aij equal to 0 for all I is not equal to j. I is not equal to j means what? These are the elements where I is not equal to j. These are the elements where I is not equal to j. That's called the diagonal matrix. What are the? ఇక్కడ చూడండి అమ్మా. For non-diagonal elements must be zeros. Diagonal elements may or may not be zeros. 1 0 0 0 2 0 0 0 0. This is also a diagonal. 1 0 0 0 0 0. It is also a diagonal. What is the condition here? Non-principal diagonal elements must be zeros. ఏమో అర్థమవుతుంది కదా? All of your understanding? Non-principal diagonal elements are the zeros. Principal diagonal elements may or may not be zeros. Then it is called the diagonal matrix. Next, let us go to the scalar matrix. All of you understood what are the types of matrices? Till now we have done row matrix, column matrix, rectangular, square matrix, null matrix, upper triangular, lower triangular, diagonal. Yes. Scalar matrix. Scalar matrix. Scalar matrix. What is the definition of the scalar matrix? K 0 0 0 K 0 0 0 K. First we are discussing concepts, then numericals. After the concepts we have numericals PDF also, right? Hello. What is the definition of this one? Aij equal to K. Aij equal to K for all I equal to j. Yes or no? Aij equal to K for all I equal to j. And 0 for all I is not equal to j. Then it is called a scalar matrix. Scalar. K is the scalar. 2 0 0 0 2 0 0 0 2. Is it scalar or not? Scalar. If k is equals to 1, what happens? K is equals to 1. What happens? 1 0 0 0 1 0 0 0 1. What is the name of this matrix is called? Identity matrix. Identity matrix. What is another name of identity matrix also called? Unit matrix. Unit matrix, identity matrix. So, unit matrix is what type of matrix? It is a scalar matrix. And also you can say it is a diagonal matrix. You all understanding? అర్థమైంది కదమ్మా? Unit matrix అనేది ఏమైతుంది? Scalar and also diagonal. But all diagonal need not be unit matrix. Is it clear to all of you? Yes. Next. Transpose matrix. Till now, what are the properties are completed? Properties of the trace. Keep the star mark. Properties of trace very important. How many properties I explained? 7. All 7 very important. నేను ఎప్పుడైనా ప్రాపర్టీ చెప్పేటప్పుడు మీకు కొత్తగా అనిపిస్తే ఏం చేస్తారు? Whenever it is new, keep the star mark and read 1 to 3 times. It becomes easy. No need to worry about the gate. Don't think that gate is very tough, complex exam. Think positively, work hard. Hmm? ఆ, నిన్న చూశారు కదా ఇండియన్ క్రికెట్ టీం ఎలా ఆడారు, అలా అనుకోవాలి మనం కూడా. కమాన్, అంతకంటే ఎక్కువ అనుకొని ప్రిపేర్ అవ్వాలి. కమాన్, ఎస్, కంప్లీటెడ్. ట్రాన్స్పోజ్ మ్యాట్రిక్స్, రైట్ డౌన్. ట్రాన్స్పోజ్ మ్యాట్రిక్స్. హలో, ట్రాన్స్పోజ్ మ్యాట్రిక్స్. Transpose matrix. Listen here. It is represented as A transpose A prime. A transpose A prime notation. Determinant shortcut, all of you understood? No confusion. But wherever determinant is applicable, try to apply slowly. It becomes practice to you. Don't worry. Yeah, coming to next transpose of the matrix. A matrix obtained after interchanging rows and columns. Rows and columns. If you take the example A, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is A transpose here? A transpose is what? 1, 4, 7, 2, 5, 8, 3, 6, 9. 1, 4, 7, 2, 5, 8, 3, 6, 9. That is A transpose. ఏమా ట్రాన్స్పోజ్ క్యాలిక్యులేట్ చేయడం తెలుసు కదా అందరికీ? ఎవ్రీబడి నోస్ ట్రాన్స్పోజ్. వెరీ గుడ్. నౌ ప్రాపర్టీస్ ఆఫ్ ట్రాన్స్పోజ్, వెరీ వెరీ ఇంపార్టెంట్. ప్రాపర్టీస్ ఆఫ్ ట్రాన్స్పోజ్. Properties of transpose, very very important. First one, A transpose whole transpose. What is the answer? A transpose whole transpose is A. Second, A plus B whole transpose. A plus B whole transpose is also previous gate. What is A plus B whole transpose? A transpose plus B transpose. Very good. That is the second property. Third property, Ka whole transpose. K is the constant. Anybody? What is the Ka whole transpose? K into A transpose. K into A transpose. K is the constant. K into A transpose. K is the constant. AB whole transpose. What is AB whole transpose? B transpose into A transpose. This is a previous gate direct bit. This is also a previous gate direct bit. AB whole transpose. What is the formula of AB whole transpose? B transpose into A transpose. Very good. Next, fifth, fifth. A inverse whole transpose. A inverse whole transpose. A transpose whole inverse. All these five properties are very important. All these five properties of the transpose of the matrix. All five are very important. Transpose matrix. Sometimes transpose is represented. What is the notation? Prime notation also. Prime. Yes, very good. So, is there any new property you are observing here? Anything you are observing new means keep the star mark, again revise that. Yes, coming to next. Completed. How many? 5. Trace how many? 7. Like that. Next. Symmetric matrix. Symmetric matrix. Hello. What is condition for symmetric matrix? Everyone. Yes, only few members are responding. What is the condition for symmetric? A transpose equal to A. Everybody knows. Very good. A transpose equal to A is a previous gate. Direct condition itself is a previous gate. A transpose equal to A. Yeah. If you take the example here, example A is equals to 1, 2, 3, 2, 3, 4, 5, 5, 6. Hello. Is this symmetric or not? Yes or no? It is a symmetric. Everybody understanding? Very good. Next. 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9, 9, 10. Is this symmetric or not? What is the condition for the symmetric? A transpose equal to A. Condition for symmetric is A transpose equal to A. So this is a 3 by 3 matrix, 4 by 4. 3 by 3, 4 by 4. Here how many maximum distinct elements? చూడండి అమ్మా ఇక్కడ distinct elements maximum ఎన్ని ఉన్నాయి చెప్పండి. How many maximum distinct elements we are having? Maximum distinct different elements are how many? 6. 6 or 9? 6. How many maximum distinct elements are there? 10. 10. జాగ్రత్తగా వినండి అమ్మా. Observe clearly what I am saying. Maximum distinct elements are how many here? 6. How many maximum distinct elements here? 10. If you take the n by n matrix, what are the maximum distinct elements? We have one formula. Maximum distinct elements. Maximum distinct elements. Maximum distinct elements in symmetric matrix. Symmetric matrix. Maximum distinct elements in symmetric matrix of nth order. Of nth order. What is the formula? N into n plus 1 by 2. ఇది ఒకటి జాగ్రత్త గుర్తుపెట్టుకోండి అమ్మ ఫార్ములా n into n plus 1 by 2. Is this satisfying or not? Check. This is what? 3 by 3. Carefully observe 3 by 3. For 3 by 3, is this satisfying or not? 3 into 4 by 2. What is the answer? 6. For 5 by 4 by 4, is it satisfying or not? 10. Is it clear to all of you? Everybody understanding? What is the formula? N into what does it represent? What does it mean? It represents maximum number of distinct elements in the nth order symmetric matrix. Everyone understanding? If it is a fifth order, hello, 5 by 5. If you take 5 by 5, what are the maximum distinct elements in 5 by 5? 5 into 3, 15. 15 you will get. Okay. So that is a formula for maximum number of distinct elements. N into n plus 1 by 2. Very important. Next. What is the formula to calculate symmetric? Formula to calculate symmetric. Symmetric matrix. What is the formula to calculate symmetric matrix? Half into A plus A transpose and also A plus A transpose. 2 into A plus A transpose. చూడండి అమ్మా, observe, these are all symmetric matrices only. How many of you have studied these matrices in your BTech? Symmetric matrix. How to calculate the symmetric matrix formula? Half into A plus A transpose. For any given matrix, how to calculate symmetric matrix? Half into A plus A transpose. This is a previous gate question. A plus A transpose. మీకు ఎగ్జాంపుల్ ఏం అడిగిండమ్మా? A plus A transpose represents what type of matrix? A plus A transpose represents what type of matrix? Symmetric. That's the previous gate. Yes. Okay. Let us take one example to calculate how to calculate the symmetric matrix. Yes. Okay, na? Right. So if you observe an example here, matrix A is given 1, 2, 3, 4, 5, 6, 7, 8, 9. Matrix A is given 1, 2, 3, 4, 5, 6, 7, 8, 9. What is its symmetric matrix? What is the symmetric matrix for this? 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the formula for this symmetric matrix? Half A plus A transpose. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is A plus A transpose. What is A transpose here? 1, 4, 7, 2, 5, 8, 3, 6, 9. Yeah, check this one. Add 1 plus 1, 2 by 2, 1, 1, 3, 3 plus 7, 10 by 2, 1, 3, 5, 3, 5, 7, 5, 7, 9. That is the answer. 1, 3, 5, 3, 5, 7, 5, 7, 9. That is the answer for the. Yeah, is this symmetric or not? Hello. For non-symmetric, given is what? Non-symmetric. For non-symmetric matrix, we are getting the symmetric matrix. What is the formula to get the symmetric matrix? Half A plus A transpose. You can use A plus A transpose this formula also. Next. See, once the types of matrices topic is completed, we have some numericals also. All around 20 numericals, 20, 25, all are previous very important questions on types of matrices. Right. Every topic we will discuss on every topic some 15 to 20 questions on all that very important previous gate. Yes. Let us go to skew symmetric. Is this completed? Skew symmetric. What is the condition for skew symmetric? Skew symmetric matrix. What is the condition for the skew symmetric? A transpose equal to minus A. A transpose equal to minus A. If you take the example here, 0, 1, 2, minus 1, minus 2, 0, 3, minus 3, 0. Yeah, is this skew symmetric or not? Yeah, what is the condition for, is it satisfying A transpose minus A? Observe here. A transpose, what is A transpose? 0, minus 1, minus 2, 1, 0, minus 3, 2, 3, 0, which is equals to what again? Minus A. A transpose equal to minus A. Everybody understanding? Example, A transpose equal to minus A. Let us take one more example. One more example here. 0, 1, 2, 3, minus 1, minus 2, minus 3, 0, 4, 5, minus 4, minus 5, 0, 6, minus 6, 0. This is another example. Skew symmetric, another example. Yeah, this is also satisfies A transpose equal to what? Minus A. A transpose equal to minus A. Now, how many distinct elements we are having here? How many distinct elements? ఇక్కడ చూడండి అమ్మా maximum distinct elements how many are there? 1 2 3 1 2 3 minus 1 minus 2 minus 3 including 0. How many? 7. How many distinct elements are there? 7. In this case, if you observe here 1 2 3 4 5 6 minus 1 minus 2 minus 3, how many here? 6 plus 6 12 plus 0 including 13. Everyone understanding? What are the maximum distinct elements here? 7. Here it is 13. If you take the n by n, maximum distinct elements, maximum distinct elements, what is the maximum distinct elements is equals to, what is the formula? N square minus n plus 1. Remember this formula also. Maximum distinct elements is n square minus n plus 1. Yes. Maximum distinct elements are n square minus n plus 1. What is the formula to calculate skew symmetric? Yeah. Huh? Direct class. Huh? 5 minutes break. Huh? 1 minute. 1 minute. Break. See, just we started session at 10:30. 1 hour. Vinandi. Wait. We'll plan that. Yeah. So what is the formula for the skew symmetric matrix? Of A minus A transpose. One నిమిషం. Break. See, సార్ చెప్పారు బ్రేక్ ఉంది కదా అఫీషియల్గా అఫీషియల్ సి మళ్ళీ మీకు లంచ్ కూడా తొందరగా స్టార్ట్ అవుతుంది కదమ్మా ఎన్ని గంటలకు లంచ్ మీకు మరి అది కంటిన్యూ 12:30 వరకు చెప్పుకుందాము వినండి మామూలుగా క్లాస్ ఎన్నింటి వరకు అమ్మ వెళ్ళేది 1 వరకు 12:45 సైలెంట్ వినండి అమ్మ జస్ట్ లిజన్ our session was started late little bit. సో రేపు అయితే కొంచెం తొందరగా ప్లాన్ చేస్తాం సెషన్ కనుక రేపు బ్రేక్ తీసుకుందాం ఈరోజు వరకు అయితే కూర్చోండి రైట్ వీళ్ళు రారా ఓకే ఎస్ ఒక నిమిషం వినండి అమ్మా మామూలుగా మేము బయట క్లాస్లో డైలీ 8 hours గేట్ క్లాస్ ఉంటుంటుంది వినండి 8 hours మొత్తం వింటారు స్టూడెంట్ ఒకటే బ్యాచ్ స్టూడెంట్స్ మనం క్లాస్ కూడా లేట్గా స్టార్ట్ చేసినాము కంటిన్యూగా 1 వర్క్ చెప్పేసుకొని క్లోజ్ చేద్దాము వినండి లిజన్ యా అవర్ సెషన్ ఈజ్ డిలేయింగ్ వెయిట్ A transpose, write down types of matrices. Yes. Yeah, what is the formula for skew symmetric? Half A minus A transpose. Hello. What is the formula for the skew symmetric? Half A minus A transpose. 2 into A minus A transpose. మీరు షెడ్యూల్ ఏంటి పర్ఫెక్ట్ ప్లాన్ లేదా అది 5 minutes వదిలిపెట్టేసి వస్తాను లంచ్ బ్రేక్ మళ్ళీ నెక్స్ట్ క్లాస్ ఎన్నిటికి సిలబస్ అవ్వదు కదా ఆన్లైన్లో ఓకే సో దట్ ఈస్ half A minus A transpose 2 into A minus A transpose A minus A transpose. This all comes under what? Skew symmetric matrices. Write down one numerical based on this. Skew symmetric. A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Hello. A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. What is its skew symmetric matrix is equals to half A minus A transpose 1, 2, 3, 4, 5, 6, 7, 8, 9 minus see ఒక హాఫ్ అన్ అవర్ కూర్చోండి అమ్మా తర్వాత బ్రేక్ తీసేసుకొని కూర్చోండి డోంట్ షౌట్ యా 1 2 3 4 5 6 7 8 9 minus of what is A transpose 1 4 7 2 5 8 3 6 9. What is its simplification here? 1 minus 1 is 0, 2 minus 4 is minus 2 to minus 1. This is minus 2, 1 0 minus 1. 7 minus 3, 4, it is a 2, 1, 0. Yeah, this resultant is what? After finding what is the resultant, it is a skew symmetric matrix. Yes or no? Skew symmetric matrix. And we have very, very important note. Very important note. Every square matrix can be expressed as every square matrix can be expressed as every square matrix can be expressed as sum of symmetric matrix and skew symmetric matrix. Any square matrix can be expressed as the sum of symmetric and skew symmetric. That is also very important. A is equals to half A plus A transpose plus half A minus A transpose. Hello. Half A plus A transpose plus half A minus A transpose. That is the answer. Any square matrix can be expressed as the sum of symmetric and skew symmetric. Sum of symmetric and skew symmetric. Yes. So we have one previous gate question based on this. Every square matrix can be expressed as sum of symmetric and skew symmetric matrix. Yes. Yeah. Symmetric matrix is given. Hello. Symmetric matrix is given minus 4, 4, 2, 4, 3, 7 by 2, 2, 7 by 2, 2. Skew symmetric is given. Skew symmetric matrix is 0, minus 2, 3, 2, 0, 7 by 2, minus 3, minus 7 by 2, 0. Then, hello. What is the original matrix? Symmetric skew symmetric matrix is given. What is our matrix P? What is the matrix? How to get the matrix? Original matrix? We have to add both of them. Listen. Symmetric skew symmetric is given. What is the original matrix? How to get the original matrix? Sum of the symmetric and skew symmetric. What is the result of this one? Minus 4, 4 minus 2, 2, 5, 6, 3, 7, minus 1, 0, 2. This is a recent previous gate question. What is that? Symmetric matrix to skew symmetric is given. What is the matrix? Original matrix. What you have done? Sum of the symmetric and symmetric plus skew symmetric is equals to what? Symmetric matrix. Skew symmetric matrix is the original matrix A. A is equals to symmetric and skew symmetric matrix. Yes. Yeah, that is about to symmetric and skew symmetric conditions. What is the condition for the symmetric matrix? Symmetric matrix condition is A transpose equal to A. Skew symmetric is what? A transpose equal to minus A. And this is very important theorem. Next. Let us go to the orthogonal matrix definition. Clear na? Answer is cleared? Orthogonal matrix. Orthogonal. Hello. What is the condition for the orthogonal matrix? See, A into A transpose into A is equals to I. Orthogonal matrix condition. A into A transpose into A is equals to I. And what are the properties of orthogonal matrix? Properties of orthogonal. What are the different properties of orthogonal matrix? First one is determinant of orthogonal matrix is plus or minus 1. Second is what? A inverse is equals to A transpose. These are the two properties. All two properties are very important. Condition, two properties. All are important. Next, if you take the example here, what are the examples? Examples observe here, sin theta minus cos theta, sin theta. This is a example. Hello. Cos sin theta, cos minus cos theta, sin theta. This is the example of the what type of matrix? Orthogonal. Check whether it is satisfying or not. A into A transpose. A into A transpose. Sin theta minus cos theta, sin theta into, it's a transpose is what? Sin theta cos theta minus cos theta sin theta. What is the result of this one here? Observe, multiply it. Sin square theta plus cos square theta is the 1. Sin theta cos theta minus sin theta cos theta is 0. Sin theta cos theta minus sin theta cos theta 0, cos square theta sin A into A transpose equal to I. So that is example, sin theta minus cos theta sin theta is example. What are the other example? For orthogonal matrix, what are the other examples here? ఇక్కడ చూడండి అమ్మా. Listen. It's a transpose. Take its transpose. Sin theta, cos theta, minus cos theta, sin theta. This is also example. This is also example of what? Orthogonal matrix. Yes. Observe the examples of orthogonal. Orthogonal matrix examples. Yeah. Coming to next. Yeah. What is another one? Observe. Cos theta, sin theta, minus sin theta, cos theta is also example of orthogonal. Cos theta minus sin theta, cos theta. So this is also example of these are all examples of what? Orthogonal matrices. ఒకటి క్వశ్చన్ చెప్తున్నాను, మీరు ట్రై చేయండి, వస్తుంది ఆన్సరు. మ్యాట్రిక్స్ ఏ ఇచ్చిండమ్మ మనకి, ఇది 2026 బిట్. మ్యాట్రిక్స్ ఏ ఇచ్చాడు మనకి, లైక్ సైన్ టీటా మైనస్ కాస్ టీటా సైన్ టీటా. దిస్ టైప్ ఆఫ్ మ్యాట్రిక్స్ ఈజ్ గివెన్. ఈజ్ ఆస్కింగ్ ఏ పవర్ 2026. A power 2026 at theta is equals to 2 pi by 5. A power 2026 at theta is equals to 2 pi by 5. Try this. A is the answer. You will get A. మీరు ఒకసారి ఏ స్క్వేర్ ఫైండ్ అవుట్ చేయండి. ఏ స్క్వేర్ ఫైండ్ అవుట్ చేసిన తర్వాత దాంట్లో నుంచి ఏ స్క్వేర్ టు ది పవర్, once you will get a square to the power of how much it is? 101316, like that. 2 pi by 5 angle, substitute theta equal to 2 by 5. Check that one, you will get the answer A. Check చేయండి అమ్మా, మనకు ఆన్సర్ వస్తుంది. Is it clear to all of you? Hello. Orthogonal matrix examples cleared? Yeah. Coming to next. What are the other orthogonal matrix examples? Observe here. Other orthogonal matrix, A is equals to 1 0 0 0 0. Listen. Yes. ఇక్కడ 4/5 ఉంది కదమ్మా. This 4/4. All 4 examples substitute. Whatever the 4 examples I explained, substitute all 4 examples here. They are also orthogonal. 0 0 1 0 0. All 4/4. Substitute all 4 examples. What are the 4 examples I discussed here? Sin theta, cos theta, minus cos theta. All 4 substitute. There also becomes a orthogonal. See, properties of orthogonal, if you are observing, this is a directly previous gate bit. So this is directly previous gate bit. A transpose equal to A inverse. And what are the other examples you can write here? A is equals to 0, 0, 1, 0, 0. This is also a orthogonal. Yeah. 0, 0, 1, 0, 0. This is also a orthogonal. So totally, ఇక్కడ observe చేయండి అమ్మా. Yes. Yeah, stop discussions. Yes. See, how many examples are there in this? 4. Here also 4, 4, 4. Total how many are there? 16 plus 4. Totally 20 examples I discussed for the orthogonal matrix. Very, very important. 20 examples for orthogonal. Yes. Yes. Coming to one more question from the orthogonal previous gate. See here, Q is equals to, hello, concentrate. Q is equals to 3 by 7, 2 by 7, 6 by 7, minus 6 by 7, 3 by 7, 2 by 7, 2 by 7, 6 by 7, minus 3 by 7. 3 by 7, 2 by 7, 6 by 7, minus 6 by 7, 3 by 7, 2 by 7, 2 by 7. And he asked what is the question is here? Q inverse is equals to what? What is Q inverse? How to get the Q inverse? Q transpose. And he is saying that Q is orthogonal matrix. What is Q inverse? Q inverse is the Q transpose. Q transpose. What is the Q transpose here? 3 by 7 minus 6 by 7, 2 by 7, 2 by 7, 3 by 7, 6 by 7, 6 by 7, 2 by 7, minus, that is answer. Understanding? Direct wait. See, without the knowledge about the property of orthogonal, it is difficult to answer it. Q inverse అంటే ఏం చేస్తారమ్మా మీరు? Adjoint divided by determinant takes lot of time. Next. Next, minor definition. Minor. Last one is clear now? No confusion, last one. Next, minor definition. Minor. What is a minor definition? Yes. Minor ఎలా calculate చేస్తామమ్మా? How to calculate minor? 1, 2, 3, 4, 5, 6, 7, 8, 9. Minor of the 2. If you will ask the minor of the 2, how to calculate the minor of the 2? Delete the 2. Determinant of what? 4, 6, 7, 9. Determinant of 4, 6, 7, 9. What is its value? Determinant of 4, 6, 7, 9. 36 minus 42 minus 6. Minor of the 2 is minus 6. Next, minor of the 4. What is the minor of the 4? Minor of the 4. Delete this row and column. 2, 3, 8, 9. 2, 3, 8, 9. Yeah. 2, 3, 8, 9. Yeah, what is the minor of this one? It is 18 minus 24 minus 6. All of you know how to minor of the 4. 4 minor. Correct, na? Anything is wrong? Correct only. Cofactor. What is a cofactor definition? Cofactor. How to calculate the cofactor? Minus 1 power of I plus j into, hello, What is the difference between minor and cofactor? Minus 1 power of I plus j into minor. That is the cofactor. So if you want cofactor of the 2, cofactor of the, let us take cofactor of the 6. Tell me, what is the cofactor of the 6? You are not responding. Cofactor of the 6 is what? Minus 1 power. 6 belongs to which row? Second row, third column, second row, third column, 1 to 7, 8. What is its answer? Minus 1 into 8 minus 14. What is the answer? 6. Cofactor of the 6. What is the cofactor of the 6 here? Minus 1 power of 2 plus 3 into 1 to 7, 8. Minus 1 into 8 minus 14. 6 is the answer. Everybody understanding? Now, when minor cofactor both are equal, just tell me when minor cofactor both are equal. If I plus j is even, hello. If I plus j is even, both minor and cofactor are the equal. Yes or no? Minor cofactor both are equal. If I plus j is even, I plus j is odd. I plus j is odd. What happens? Minor and cofactor are differ with the minus sign. All of you understanding? When minor cofactor both are equal, I plus j is equals to even number. When both are differed by minus sign, I plus j equal to odd number. So that is about the minor cofactor. Next. Yeah, determinant definition. Very important. Determinant. Determinant definition. Hmm? Determinant. Laplace expansion. Determinant. Properties of determinant we have. Determinant. The Laplace expansion. The Laplace expansion. The Laplace expansion about any row or any column. The Laplace expansion about any row or any column. Yes. A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. Hello. What is the determinant expansion here? Determinant expansion is what? A11 into Vinandama. A11 into cofactor of A11 into cofactor of A11 plus A12 into cofactor of A12 into cofactor of A12 plus A13 into cofactor of A13. A11 into cofactor of A11 plus A12 cofactor of A12. Yes, tell me, is there any mistake in the formula? Yes, concentrate. Any wrong? Anything is wrong in the formula? Yeah, all of you are concentrate. Anything is wrong here. Some of you are saying that minus is required here. Minus is required or not? This is correct formula only. If you want write in terms of minors, ఇక్కడ వినండి అమ్మా, minors in terms of minus it is minus, but in terms of cofactors it is always pluses only. అర్థమవుతుంది కదా? Cofactors all are positive. Minors లో తీసుకుంటే ఏమొస్తుంది? Second term will get the minus. Is it clear? Everyone understanding? Yes. Now we have very important properties. Very important properties of the determinant. 14, 15 properties are there. Now I am going to write. There are so many gate questions from the determinant properties. Let us go. Determinant properties. Properties of determinant. Properties of determinant. First one, properties of determinant. First property, determinant of A transpose. What is the determinant of A transpose? Determinant of A. Second, determinant of Ka. K power of n into determinant of A. K is the constant. Determinant of Ka. K power of n into determinant of A. K is constant. Third, determinant of AB. Determinant of A into determinant of the B. Determinant of AB. Determinant of A into determinant of B. Fourth, determinant of A inverse. Determinant of A whole inverse. Determinant of A inverse. Determinant of A whole inverse. Or we can write 1 by determinant of A also. 1 by determinant of A. Fifth, if two rows are two columns similar, if two columns are similar, what is the determinant value? 0. If two rows are two columns similar, determinant value 0. If two rows are two columns interchanged, if two rows are two columns are interchanged, what happens? Two rows are two columns are interchanged, what happens? Two rows are two columns are interchanged. Determinant value remains same. Determinant value remains same, but sign changes. Determinant value remains same, but sign changes. Determinant value remains same, but sign changes. Yes or no? Determinant value remains same, sign changes. Yes. All properties are very important. Properties of the determinant. Next. Seventh property. Determinant value of, hello, determinant value of triangular matrix, determinant value of triangular diagonal scalar matrix. What is the determinant value of the triangular matrix? What is the determinant value of the diagonal matrix? You are not respond. Diagonal matrix, what is the determinant value? Product of principal diagonal elements. Yes or no? Determinant of the diagonal matrix, product of the principal diagonal elements. Product of principal diagonal elements. Determinant value of the triangular diagonal scalar matrix is equals to product of the principal diagonal elements. Next, determinant value of singular matrix. Determinant value of singular matrix. What is the determinant value of the singular matrix? 0. Singular matrix, what is the determinant value? 0. Determinant value of the singular matrix is 0. Next, determinant value of non-singular matrix. Non-singular matrix not equal to 0. Determinant value of non-singular matrix not equal to 0. Hello. Determinant of unit matrix is how much? Determinant value of unit matrix of order n. 1. Unit matrix determinant value 1. 11th property. Determinant value of KA1, B1, C1, KA2, B2, C2, KA3, B3, C3. Can you guess what is the determinant value of this one? Any row or column multiplied by some constant, entire determinant also multiplies. K into A1, B1, C1, A2, B2, C2, A3, B3. Understanding? Any row column multiplied by K, entire determinant also multiplies. Is this clear to all of you property? Right. 12th property. If you observe the 12th property, KA1, KA2, KA3, LB1, LB2, LB3, MC1, MC2, MC3. Now what is the determinant of this? Anybody? K into L into M. Huh? Yes or no? Entire determinant multiplies by what? KLM into A1, B1, C1, A2, B2, C2, A3, B3, C3, K into L into M. కేఎల్ఎం ఎక్కడో విన్నట్టు అనిపిస్తుంది, వదిలిపెట్టేయండి, మనకు అవసరం లేదు. ఏందమ్మా కేఎల్ఎం అంటే ఏంది? ఓకే, రైట్. సమ్ కాన్స్టెంట్స్, డోంట్ థింక్ మచ్ అబౌట్ దట్. This is the one flight name in Netherlands country. One flight name in Netherlands country. మరి మీరేమో అనుకుంటున్నారు? మీరేమనుకుంటున్నారమ్మా? రైట్. Coming to next. 12th property. How many? All 12 are clear to all of you? 12 properties. 13th property. Wait. 13th property. Hello. 13th property is what? A1 plus B1 C1 D1, A2 plus B2 C2 D2, A3 plus B3 C3 D3. Yes, tell me outright this property. If any row column is the sum of the elements, that can be expressed as what? Sum of the two determinants A1 C1 D1, A2 C2 D2, A3 C3 D3 plus B1 C1 D1, B2 C2 D2, B3 C3 D3. Is this property clear to all of you? Any row column is sum of the two elements, that can be expressed as what? Sum of the two determinants. Is this clear to all of you? Yes. A1 C1 D1, A2 C2 D2, A3 C3 D3. Total how many properties are there? 13. All properties are very, very important. All properties are very important. Related to which one? Determinant properties. Yes. Determinant, all these properties are very important. Yes. What is the determinant of the singular matrix? 0. Non-singular matrix? Not equal to 0. Yeah. Here I am going to write some questions. Yes. Now it's your time to answer. Completed. Yeah. What happened? Wait, wait. Okay, note down, note down. Yes. Silence. Hello. Now we are going to solve determinant. On one slide, I will write around 4 or 5 questions. Try your answers. Now all of you understood cut in properties. Will do. How many of you will solve correct answers? Yes. First one, A is 3 by 3 matrix. Hello. A is a 3 by 3 matrix. Determinant of A is 2. Determinant of 2A is what? Try all of you. This question, this type of questions repeated many times. A is 3 by 3 matrix. Determinant of A is 2. What is the determinant of 2A? This type of questions are repeated many times. What is the correct answer? అమ్మా 4A అనేది ఈజీ అని 4 అని చెప్తున్నారు చాలా మంది. కరెక్ట్ ఆన్సర్ చెప్పండి అమ్మా. టెల్ మీ కరెక్ట్ ఆన్సర్. What is the property we have to apply here? Determinant of Ka. What is the determinant of Ka? K power of n into determinant of A. Huh? What is the answer? 2 cube into determinant of A. 16 is the answer. 16. It's not the 4. 16 is the correct answer. Next. Second. Determinant of A. Hello, determinant of A is 5. Determinant of B is 40. What is determinant of AB? This is also previous gate. What is the answer? Hello. Determinant of A is 5. Determinant of 40. Observe your property. Determinant of AB. 200 is the answer. 5 into 40. 5 into 40. 200 is the answer. Next. Fifth one. Yeah, third one. Hello. Determinant of 132. Observe here 132, 0, 5 minus 6, 2, 7, 8. This determinant value is 26. Determinant of 2, 7, 8, 0, 5 minus 6, 132. What is the answer? These are all previous gate. What is the answer? Determinant of 132, 0, 5 minus 6, 2, 7, 8 is 26. What is the answer for this one is the minus 26 is the answer. Minus 26. Why minus 26? First and last row got interchanged. If two rows are interchanged, determinant value remains same, sign changes. Minus 26 is the correct answer. Minus 26. Yes. Minus 26 is the correct answer. Yes. Let us move. Minus 26. Fourth question. Yes. Determinant of 130. Which question? Wait. Just 5 minutes. 2, 6, 2, 6, 4, minus 1, 0, 2. Hello. Yes. It is a minus 12, then determinant of 260, 412, 8 minus 204. What is this answer? Hello, everyone. Little bit tricky question. Everyone, what is the correct answer? Hello. What is the difference from year to year? Year to year, what is the difference? Every element is multiplied by what? 2. Every element got multiplied with the 2. Yeah. If determinant of A is minus 12, determinant of A is minus 12. What is the determinant of 2A? 2 cube into determinant of A, 8 into minus 12. Minus 96 is the answer. Minus 96. But most of the students, what they will say? Minus 24. Most of the students, they will say minus 24. Minus 24 ఎందుకు చెప్తుంటారమ్మా చెప్పండి ఇక్కడ ఎవ్రీ ఎలిమెంట్ మల్టిప్లైడ్ 2 కదా సో 2 తోటి ఇట్స్ నాట్ కరెక్ట్ minus 96 is the correct answer. Yes. Yes. Yeah, determinant of 1, 2, 3, 1, 4, 2, 2, 6, 5. Yes. All of you try this question. What is its determinant value? Determinant of 1, 2, 3, 1, 4, 2, 2, 6, 5. Think cheyandi. Yes. Determinant value of 1, 2, 3, 1, 4, 2, 2, 6, 5. What is the answer? Listen, very important point. Sum of the two rows is third row. Please listen. 1 plus 1 is what? 2. 2 plus 4 is 6. 3 plus 2 is 5. If sum of the two rows is the third row, sum of the two columns is the third column, determinant vanishes. What is the determinant value directly straight away? 0. Yes. Determinant any property చెప్పామమ్మా మనం 13. Along with that, remember one more is what? Yes. Sum of the two rows is the third row. Sum of the two columns is the third column. Determinant vanishes. That's very important property. Is it clear? Determinant vanishes. All of your understanding? Yeah. What is the determinant of A inverse property? Determinant of A inverse. Determinant of A whole inverse. Yes. A is equals to Aij with order 3 by 3. A is Aij with order 3 by 3. Aij is equals to I minus j. What is the determinant of value? What is the determinant? Yes. So all of you remember this type of question we have done already in the beginning of the matrices. Yes. What is the matrix here? 0, 1, 0, minus 1, minus 2. 1, 0, 1, minus 1. Yeah. This is a, yes, skew symmetric matrix. Emma? Yes. Yeah. One important note, determinant value of skew symmetric matrix with odd order is 0. See, this is a odd order skew symmetric matrix. Is it skew symmetric or not? Skew symmetric. Determinant value of skew symmetric matrix with odd order is 0. Its determinant value 0 straight away. So then after that we have determinant. Then what is the next one? Adjoint and inverse. Adjoint, inverse matrix. After that we have what is the rank rank of the matrix system of linear equations, eigenvalues and eigenvectors. Just wait. Don't shout. Break, lunch break.